Y is a function of x. How to find the maximum and minimum value of y?
I'll first raise a problem. Suppose you are a pen manufacturer and you are selling pens in 4-liter can. Cost of paint is actually cost of material of paint plus cost of the can. You can earn more profit by a suitable selection of the shape of the can. Cost of the can depends, cost of the empty can depends on the surface area of the can. Because greater the surface area, greater is the material that has been used to make the can. Hence, to reduce the cost of can, you will choose such a shape that the surface area of the can becomes minimum. I have shown in drawing, I have shown two different shapes. Each shape has a volume of 4 liter. You can see the shape of this. Its cross-sectional area is quite larger than the other one, and its height is quite smaller compared to the other one. So this has a volume of 4 liter. The other one also has a volume of 4 liter, but the surface area of this can is different from the surface area of this can. Surface area depends on what? Surface area of a cylinder is given by 2 pi r into h. H is the height of the cylinder and r is the radius of the cross-sectional area of the cylinder. So the volume is 4 liter while surface area depends on two parameters. One is h and the other one is r. By suitably choosing the ratio h to r, you can reduce the surface area of the can while keeping the volume fixed at, for example, 4 liter. So to understand this, first we will have to know the concept of maximum and minimum, which is actually an application of derivative. So follow my lesson to understand how to find the condition for maximum and minimum value of y, where y is a function of x. So this is the cylindrical container. Height of the container is h and radius of its cross section is r, and it has a fixed volume, for example 4 liter. Let us write expression for volume of the cylinder equal to pi r square h and its total surface area. Total surface area means the area of the curved surface plus the area of the two flat surfaces. So total surface area is A equal to area of the curved surface, which is 2 pi r h, plus area of the two leads, pi r square plus pi r square, equal to 2 pi r h plus 2 pi r square. So volume of the cylinder is V. We should understand in the very beginning that V is constant. V is constant, but surface area A is variable. A equal to a function of both r and h. See this expression, A depends on r and A also depends on h. So in order to write this in the form y equal to f x. We'll have to write this in this form. We'll have to write either r in terms of h or h in terms of r. A equal to is 2 pi r h, 2 pi r into, let us replace h. H equal to v divided by pi r square. Plus 2 pi r square. This is equal to pi r cancel, 2v by r plus 2 pi r square. Let us study this expression of the surface area. It depends on r because r is the only variable. We have already understood that volume of the container is constant. Hence, A equal to function of r. This equation is comparable to y equal to function of x. So in this expression, A stands for, or A represents y and r represents x. We'll have to find the value of r for which A will be minimum. So for this, dA by dr should be 0. Now what is dA by dr? It is the derivative of area A with respect to r. It is comparable to dy by dx. Now the question is, why it should be 0? To understand why dA by dr should be 0, we'll have to first understand the basic meaning of dy by dx. I have drawn here y as a function of x. This is the curve representing y as a function of x. We will understand what exactly is dy by dx. On the graph y versus x, this is a point with a coordinate of xy. So coordinate of this point is xy. Dx, which represents a small increment in the value of x, is this much, and dy, which represents a small increment in the value of y, is this much. So dy by dx, dy by dx is actually slope of this tangent. The tangent is drawn. I have drawn the tangent to y equal to fx curve at the point xy. So dy by dx is actually perpendicular by base for the tangent, and therefore it is the slope of the tangent. So we should know that derivative of y with respect to x, that is dy by dx, is actually the slope, means tan theta, of the tangent drawn to y equal to fx curve at the point xy. This is the curve that represents y as a function of x. We find that at this point y has a maximum value. Corresponding to this point, the value of x is x1. That means at x equal to x1, y has a maximum value. Again, we find that at x equal to x2, y has a minimum value. What is the mathematical condition that corresponds to this maximum value of y and the minimum value of y? For that, let us draw a tangent to the curve at the point where y is maximum. At this point, let us draw a tangent. The slope of this tangent, what is slope? Slope is tan theta. What is theta? Theta is the angle made by the tangent with positive x-axis. So since this line, this tangent is parallel to x-axis, it makes a zero angle with the x-axis. So the slope of this point, tan theta equal to 0, that means for this point dy by dx is 0. Now let us move to the point where y is minimum. At this point y is minimum. Let us draw a tangent to the curve at this particular point, and we find this tangent is also parallel to the x-axis. So it makes a zero angle with x-axis, or in other words, tan theta for this particular tangent is 0, and hence the dy by dx, value of dy by dx corresponding to this minimum value of y, corresponding to this position, is also 0. So now there is a problem, because both for maximum value of y, dy by dx equal to 0, and minimum value of y, dy by dx equal to 0. So how will we know whether at x equal to x1 y is maximum, or at x equal to x2 y is maximum? Hence there has to be another set of condition. To find that condition which will identify whether y has maximum value at a given value of x, or it will have a minimum value at a given value of x, we will consider the change in slope. With respect to change in x, we will move in this direction along positive x direction. So value of x will continuously increase. We'll see the variation in the slope. Okay, slope changes from, say, tan theta 1 to tan theta 2. Tan theta 1 to tan theta 2. This is the change in slope. Now, as x increases, dx is obviously positive, because what is dx? dx equal to x final minus x initial. As you move in the direction of positive x-axis, x final exceeds x initial. This is x initial, this is x final. So that's why x final is greater than x initial. As a result, this dx is greater than 0. Okay. And what about d tan theta? What about d tan theta? Tan theta decreases, because you can see that angle has decreased from theta 1 to theta 2, then from theta 2 it will decrease to 0. So the value of tan theta gradually decreases. From a positive value, it gradually decreases to 0. For example, plus 5, plus 4, plus 3, plus 2, plus 1, and then it is 0. So while approaching the maximum value of y, change in slope with respect to x, that means d by dx tan theta, change in slope with respect to x, or d dx dy by dx, see, tan theta is dy by dx, is less than 0. Okay, we can have a very clear understanding by taking a value of theta 1 and taking another value of theta 2. For example, say theta 1 equal to 60 degree and theta 2 equal to 30 degree. So tan theta 1 equal to root 3 and tan theta 2 equal to 1 by root 3. Since 1 by root 3 is less than root 3, hence tan theta 2 minus tan theta 1, it is negative, that's why it is less than 0. Okay. Now we'll consider the point where y is minimum. Again we'll move in positive x direction and we'll observe the variation, increase or decrease of the slope. As we move in this direction, the slope means tan theta 1 dash. Here the slope is negative because this angle is obtuse, greater than 90 degrees. So tan theta 1 dash is negative. So the slope is negative here. It is negative at this point. Here also the angle theta 2 dash, it is greater than 90 degree. So tan theta 2 dash is negative. So the slope is negative. What about its value? We get the value by considering the acute angle. Suppose this angle is say 60 degree and then it has dropped to say 30 degree. So what is the value of slope at this particular point? It is already minus, it is minus tan 60 degree. Means minus root 3. At this particular point, here also the slope is negative. What is this value? Value is tan 30. So minus tan 30, that is minus 1 by root 3. So what we observe that the negative value decreases, means the slope becomes less and less negative. Less and less negative, that means the slope increases. It becomes less and less negative. For example, minus 5, minus 4, 2, minus 3 to minus 2, minus 2 to minus 1. Then ultimately at this point the slope becomes 0. So while approaching the minimum value of y, the slope increases. For y minimum, as x increases, slope tan theta also increases, hence d by dx tan theta, it increases, means final value is greater than initial value. So that's why it is greater than 0, or d by dx, dy by dx is greater than 0. So we get clear-cut condition for maximum value of y and for minimum value of y. For maximum value, for maximum value of y. For maximum value of y, first of all, dy by dx has to be 0, and in addition to this, d by dx, dy by dx, which is written as, or this is written in this form, d2y by dx square, it is, as we have seen here, it is less than 0. And for minimum value of y, first of all, dy by dx, it has to be 0, and then d2y by dx square, it should be, as we have discussed here, it should be greater than 0. Okay, so these two.
Answer to the container problem is height equal to diameter. See the next video for solution.